Good morning, dear students. Today, today we are going to discuss about transmission characteristics or losses in the fiber cable, losses in the fiber cable while communication is going on. Right? You are all well known that yesterday class we discussed about um, what is fiber and what are the types of the fibers, single mode, multi mode fiber. These are all we discussed. Today we see the losses. Before going to losses, we will see some simple diagram. You can please share that diagram. Fiber types, fiber types. Yeah. Okay. Now go for the fiber types diagram. Fiber types. Fiber types. I want. Uh, this one. This one I want. Okay. Okay. So fiber types may be single mode fiber or multi mode fiber. Single mode fiber or multi mode fiber. So what is the meaning of single mode fiber? Single mode fiber means this fiber accepts fiber, it allows the light in one direction. In one direction. That is the meaning of single mode. Yeah, see this diagram. It is called, it allows only one direction. One direction means one path. Mode means what? Mode means the meaning is path. Single path. The light will take a single path in order to propagate throughout the fiber. That is the meaning of single mode fiber. Multi-mode fiber means the light may take different paths in order to propagate throughout the fiber. That is the meaning of single mode and multi-mode. Multi-mode means number of paths. That is the meaning of this. Okay. So for the single mode, generally the source is LED. I'm sorry. For single mode, the source is laser. For multi mode, the source is LED. So this type of this is a concept of designing of the simple communication link. If you want to design a simple point-to-point link, we need to select a good source, good fiber cable, and good detector like this. So if I select a single mode fiber, if I select a LED, it's not suitable one. It's not suitable one. Of course, it may be suitable, but you may get maximum loss of the light. Maximum loss of the light. Remember, what is loss? What is loss? Loss means from the transmitter side, you are simply converting the electrical signals into light signals. Light signals, right? From the input side, I'm speaking. In the communication link, what is there? In any communication link, there is a transmitter and receiver in between a medium like fiber cable. Fiber cable. So what is there in the transmitter? The transmitter having light sources, light converters. So whatever the input we are going to give, that is simply converted into light signals, right? So it is done with the help of LED or laser. But here, once the light is converted, the total light should be coupled to the fiber. The total light is coupled to the fiber. So if the source is LED, if the fiber is single mode, it is very difficult to couple the LED light into single mode fiber because maximum light is simply scattered. scattered into atmosphere. Maximum light is wasted. It is not coupled. So if the maximum light is waste means that is called loss. That is a loss. So selecting a fiber, selecting a source is very important for designing of a simple point-to-point communication links in any communication. So that in the EC people they will study in detail about how to design a good communication link. How best you can get 100% 100% coupling efficiency. Let's call it efficiency, coupling efficiency. Very less loss we want to expect when we are going to couple the light to the fiber. So if I select LED and a single mode, maximum light is wasted. So in the place of single mode, you place multi mode. It is LED and it is multi mode. What happens if your multi mode is available? You can expect less loss. So maximum light is going to be coupled to the multi mode fiber. So the combinations are like this: LED multi mode, laser single mode, like this. These are the combinations we have to select. Why we need to select these combinations like this? Because we want to reduce the loss level. This is one way of loss. And second loss is, you understand clearly. Second loss is at the end of the fiber. Light is emitted because once the light is entered into the fiber cable means here, remember always, fiber means remember always, I am speaking about core. So when the light enters into the core of the optical cable, within the core only, because of total internal reflection principle, the light is going to propagate. The light is propagated through the fiber. Right? I am going to explain about second loss. Second loss is when the light enters into the fiber cable, the light is simply propagated. At the end of the fiber, we have a receiver. No doubt, we have a receiver. Receiver. If you open the receiver mainly includes the block-like detectors. So detector, what is the detector? It may be pin diode or avalanche photodiode or sometimes simple photodiodes like this. Simple photodiode. But we want to place any one of these. So once you place this photodiode at the end, whatever the light is emitted from the end of the fiber, that will fall on the detector. So when the light is fall on the detector, so that the total photons, light means photons, the total photons converted into electrical signals, current and voltages. As we are applying the input side, we are applied electrical signals. We are applied to the LED and laser. So at the end of the fiber, the light again converted into electrical signals with the help of detector, like photodiode. So if you are, my point is, at the end of the fiber, if you are not unable to place a proper detector, proper photodiode or pin diode or avalanche photodiode, whatever the light is emitted from the end of the fiber, that is simply loss. Whatever the light, 100% light will fall, we are expecting 100% light will fall on the surface of the detector. If it is not fall, if it is scattered somewhere, if it is entered into atmosphere, that is called loss. So this is the second loss. The first loss is coupling side, in the input side. When you are coupling light source to fiber, that is the loss. And one more second loss is fiber to detector. If you are not coupling properly, that will be leakage of the light, that is going to be waste. So there are two losses we are discussing. Next loss is, see, When the light is propagating through the optical fiber, so optical fiber means here, optical fiber means through the core, when the light is propagating through the core, if the light is inside the core, there is no loss occurring. There is no loss occurring. If the light is within the core and it is reflected totally, it is propagating, that is the meaning of no loss. But what happens while the light is propagating through the core and some of the light is enters into cladding section? Listen carefully. When the light enters into cladding section, that is called loss. That is called loss. One more point I am speaking. Listen. If the light enters into cladding section, thereby into atmosphere, that is also called loss. That is also called loss. Radiative loss. That is radiated to atmosphere. The light which is going to be propagating through the core of the fiber, that is now headed to cable cladding section, afterwards atmosphere, that is called radiative losses. It is also a loss. Light is wasted. Sometimes we go for next slide. Okay. See, sometimes what type of fibers we have in order to reduce the losses. Generally, designing is very important. So as you know that the losses through the fiber are the first end of the fiber and second end of the fiber. There are three losses majorly we are expecting. One more loss we want to expect, I will tell you before discussion of this diagram of this fiber. See, from Rajahmundry to Hyderabad, we want to join the optical cables, fiber cables. We want to join. So why you need to join? You want to make a communication link. Say communication link. Communication link means you want to develop a link for a transmission purpose from one section to other section. You want to transmit something, maybe voice, video, any audio like this. So we want to develop a link from Rajahmundry to Hyderabad. So how many cables I want? I want, say for example, one cable is 1 kilometer. One cable is available. So the cable distance is 1 kilometer. So at least I want 400 cables. But remember, how do you join the two cables? That is important. I have 400 cables. You need to join the 400 cables. The question is, how do you join? We can join with the help of two ways. The first way of joining the cable is connectors. They are called connectors. You can join the two cables, one end of the fiber with other end of the cable. The two ends can be joined with connectors. Connector means a mechanical connectors are available. With these connectors, the two ends of the fiber can be joined. That is one way. Second way of joining the two ends of the cable is splicers. SPLICERS. Splicers are available. So if I want to make a long distance communication link from Rajahmundry to Hyderabad, I need at least some number of couplers and some splicing concepts, some process of splicing methods I need to implement definitely. So my point is, if you use couplers, connectors or splicing methods, your wish. But what happens? When light is propagating from transmitter to receiver through optical fiber, through core of the fiber, when the light is within the core, no problem. But when the light is entered from one cable to other cable through through a connector or through a splicer process, what happens? Remember, this is the one more loss. When the light is propagating from one fiber cable to other fiber cable through a connector, if the connector is not good, if the connector is not quality one, properly connected, or if the splicer is not good one, if the splicer is not spliced rightly, what happens? Light is leak. The light is simply leaked. That is enter into atmosphere. The light is radiated. Understand? So this is the fourth loss occurring while light is going to be transmitted. Understand my point? Because of the connectors, because of the splicers, the light may be lost. The light may be lost. This is also one more loss. I will tell you one more way of getting loss of light signal. So what is a fiber? What is a fiber? Fiber nothing but combination of core and cladding. Fiber nothing but combination of core and cladding. What is core? Core is made with some glass. What is cladding? Cladding is made with some glass and plastic combination. So core is different, cladding is different. Core is made with some one material, cladding is made with some other material. Other materials. So core having some refractive index, cladding also other refractive index. So what is fiber? Fiber is having two refractive indexes, core and cladding, two refractive indexes. But why I am strictly speaking here, if light enters into the core, because of refractive index differences, listen carefully. When the light enters into the core section of the fiber, because of refractive index difference, because core having some refractive index, cladding having some other refractive index. So this is the refractive index differences. Because of different refractive indexes in the fiber, the light is absorbed. Understand? The light is absorbed within the core. Sometimes. This is also loss. This is called core cladding losses. Core cladding losses. If a core material is not good, if a cladding material is not good means in the sense, because of different refractive indexes, the light may be absorbed. This is called core cladding loss. I will tell you one more law. When the light, when the fiber cable is straight, no problem. Because light enters, and propagating throughout the fiber. No problem. Suppose if the fiber is going to bend somewhere, for example, in home appliances or undersea, or anywhere, some cables are need to bend, isn't it? In the underground at least. See, in the underground you can see OFC cables, optical fiber cables. Somewhere on the roadside you can see there is a display that OFC cable is available. Don't dig here, isn't it? You take permission like this. So under this at underground, we are providing some cables. So the road is not straight sometimes. What happens? Road may be taking some curvature, having some curvature. So we need to bend the cable also under this ground. The cable should be bended accordingly. So the cable having some curvature, some curvature. The fiber is going to be bent. We need to bend it. But the question is, how much uh, bending of the fiber is possible? How much the fiber is going to be bent? So we need to bend the fiber, fine. But when the light is going to propagate through the core of the fiber, when the light is going to be propagated through the core of the fiber, I'm sorry, what happens? The light when the fiber is straight, no problem. The light is propagated. But when the fiber is bended, the light may take a chance, enter into cladding and towards atmosphere. That is called radiated. Light is radiated. That is called radiative losses, or also called bending losses. Bending loss. You understand how many losses occurring in this fiber. This comes under transmission characteristics. These are all transmission characteristics. Bending losses, core cladding losses, coupling losses, splicing losses, um, maybe uh, splicing losses, connector losses. Okay, these are all comes under all this. You see this slide, this slide, losses in optical fiber cable. Already I discussed absorption. Losses. See this dominant. These are predominant losses in optical fiber. When you see that these are major losses. The first one is absorption. What is absorption? This absorption is due to impurities in the fiber material. As we discussed just now, coring is some material, cladding is other material, other refractive indexes, right? So because of impurities, if you are not selecting core material properly, cladding material properly, what happens? That fiber will simply absorb the light when the light is going to propagate throughout the fiber. That is called absorption losses. Next one is material or relay scattering. Material relay scattering. Scattering may be two types. Scattering may be two types, material and waveguide. Okay, you see material means is also called relay scattering. Losses due to microscopic irregularities in the fiber. That means, what is the meaning of this? Losses due to microscopic irregularities in the fiber. When we are manufacturing any fiber, while selecting any material for fabricating core and cladding, if any irregularities in the microscopic levels in the material selections, the light may be scattered. When the light is propagating through the fiber, that light may be enters into outside world. That is called material scattering. Chromatic or wavelength dispersion. You see other scattering. Chromatic or wavelength dispersion. Dispersion means, you clearly understood the meaning of dispersion. I have a transmitting section, receiving section, in between a cable. Fine. See, from the transmit section, I want to I am sending the light to the fiber. So you imagine, you understand the light can be represented as a pulse. You know pulse, how to represent a pulse? A square signal, right? Square signal. Dear students, understand the meaning of, in order to understand the meaning of dispersion, I am explaining this. Light can be represented as a pulse signal. A pulse. Pulse means square pulse. You understand, imagine, pulse. So this type of pulses are propagating through the core. Fine. When the light is propagating through the core, like a pulses, at the end of the fiber, you cannot, at the end of the fiber means at the receiver side. At the receiver side, sometimes you cannot receive the same light pulse. Same light pulse means same duration pulse, same width of the pulse. How much width of the light pulse we are sending in the transfer side? Say for example, 1 millisecond pulse we are sending in the input side. 1 millisecond and a duration, horizontal duration. 1 millisecond pulse we are sending in the input side. But while transmission, after the transmission at the end, you cannot receive 1 millisecond pulse. You cannot receive 1 millisecond width of the pulse. You cannot receive. Why? How much millisecond pulse you are going to receive? You are going to receive 1.2 milliseconds width of the pulse. How do you say? How do you say? How do you say 1.2? Not 1.2. Maybe 0.8, 1.3, 0.9. It is not 1 millisecond. That's not my point. It's not 1 millisecond pulse, light pulse you cannot expect at the end. The reason behind is dispersion. What is dispersion? Dispersion means pulse spreading. Pulse spreading. Spreading means changing the width. Changing the width. Pulse width is going to be changed. What is the reason? Reason is what? Chromatic or wavelength dispersion. Because of the use of non-chromatic sources. Sometimes the light source is not non-chromatic. You may that is happening pulse width. Pulse width. Pulse width is going to be changed. Whatever the pulse we are sending in the input side, pulse width, the same width we cannot receive. The same pulse spreading, the same pulse spreading you are also expecting in model dispersion. See that pulse spreading or model dispersion. Pulse spreading or model dispersion. So here we say due to rays taking different paths. So pulse spreading or model dispersion means in this the rays means light rays may take different paths. Different paths. Different paths means when the light enters in the core of the fiber, light enters in the core of the fiber, always go. So what happens when the light enters in the core of the fiber? The light may take different paths. Different paths means different modes. So when the light is going to propagate in different ways, in one way, one of the ways, the light may be delayed from one fiber to other fiber. See, microseconds per kilometer. So it is delayed. When the light is delayed, that is what happens. At the end, you cannot expect the same width of the fiber. Same width of the fiber. It is called width of the fiber, width of the pulse that is going to be changed. That is called dispersion. Dispersion. Next one is coupling. Yeah, see that radiation. Radiation means radiation losses caused by bends and nicks in the fiber. See, sometimes radiations are occurred with the help of bends. As you know, as we discussed now, bends means what? Bends means bends means bends means what? Fiber is going to be bended. When the fiber is bent, light is radiating. Sometimes uh, there is a radiation loss also be occur due to nicks. Means if if you pinch the fiber, if you pinch the fiber, light may be radiated to the atmosphere. This is also the radiation loss. Next one is coupling. Coupling loss caused by misalignment or imperfect surface finishes. Coupling means, yeah, you need to couple, you need to join the two fibers. You need to join the two fibers. One end with the other end. One end with the other end. So if you place the fiber 1 axis exactly with fiber 2 axis, alignment, if the alignment is good, no problem, no loss is occurring. If alignment is not good, misalignment, the light simply loss. Imperfect surface finishes. Surface finishes means the two end surface should be properly polished before going to join. If they are properly polished and joined, no loss. If you are not if it is improper, light may be lost. Okay, dear students, you understand this all these losses. Understand all these losses. If you want, I will explain. You can see this is going to be. I will send this my class to your mails also. You can you can see. Yeah. Then dispersion. We are also explaining here intermodal and intermodal. Right. Go for next slide. Next slide, ma. Vinutma, next slide. Yeah, material dispersion, wave dispersion already discussed here. Discussed. Next, advantages. See advantages. Yeah, advantages we want. So already we know that why we need to choose this fiber for communication purpose or our industrial purpose being small size and lightweight, high signal security. So very less transmission loss compared to coaxial cables and enormous bandwidth. Bandwidth is very high and power consumption is less and you can also have good electrical isolation. So no shock with this optical fiber, generally, no shock. So these are number of advantages we have. Next slide is there. Okay. Disadvantages. See, what is the disadvantage? So the very unavoidable disadvantage is installation problems. Installation problems means if any cable is damaged or if any fiber is simply break somewhere, it is difficult to replace that fiber with another fiber. That's called insulation. Insulation. It may take high cost. That's the meaning of this high cost. Okay. Only point to point communication is possible. Point to point communication is possible means uh, unless fiber to fiber joint is not if it is correct, then only communication is possible. That is the meaning of this. If one fiber to another fiber is perfectly joined, communication is possible. If it is not, communication is not possible in this. And precise and costly instrument will be required. So we need some costly. It is economical, more economical. So it is costly. So splicing is time consuming. Splicing means, as you know, that splicing means if the two fibers need to join, suppose break, any fiber is break, any fiber is break, we need to join the two fibers again. That can be joined with the help of splicing technique. Splicing. I will tell you under heading of methods of splicing. I will discuss this splicing. So splicing is a method to join the two break fibers. Two break fibers. It's a time-consuming process. Splicing. Generally, this splicing can be done in the night times. In the night times. Why it is night time? If you do the daytime, communication signal problems is occurring with the public. So generally it is done in the night times. So it access only unipolar codes. Means it is a different issue for communication purpose. So this is the topics available in this chapter. We'll see other topics in the later next class tomorrow. Okay, you understand? Very important. This losses is very important for examination purpose also. If you have any doubt, you please ask me to call or mail me. I will share this PPT and video class to your mail ID through your CR. Okay. Thank you for uh, listening this class. Okay. Okay. Any doubts you have? Any doubts, Ma?